And this is Mission Control Houston. As promised, we have a special guest with us today remotely, calling in from Moffett Field, California at the NASA Ames Research Center. Welcome to the International Space Station update, Mark Masseri. Hi, Mark.
Hey, glad to be here.
Well, so you're working with an experiment on board that involves some small robotic spacecraft. Tell us a little bit more about your experiment.
Sure. So my time is kind of split over two experiments right now. The first one is the Human Exploration Telerobotics Technology Demonstration Mission. And basically, it's exploring how telerobotics can take on routine, highly repetitive, or dangerous tasks to improve human space exploration missions. Within HET, my project called Smart Spheres is using the Spheres platforms that were developed by MIT and flown to station back in 2006. Basically, we adapted a Google Nexus S smartphone, and it flew on up to the ISS on STS-135 last year. Basically, what we do is we connect the smartphone to the sphere, and then the smartphone is able to tell the spheres where it would like to fly, and while it's doing this, it communicates with the ground and provides video and other information about what's happening. The other experiment that I work with, I'm the Spheres engineering manager for the ISS facility. So basically myself and a whole host of other people at Ames and Marshall and Johnson Space Center work to assist other groups with experiments that they want to perform on the Spheres platforms. So these groups can be inside of NASA, outside universities, and even outside companies. And so basically my team assists in the testing, verification, and technical support of all these experiments.
Okay, and Mark, and I don't know if you can see it right now on NASA TV, but we've got some video that was recorded earlier last week as Don Pettit worked with the Sphere satellite, so we're kind of watching some video there. Okay. You mentioned this is involving a smartphone. Is there an app for that?
Yeah, actually, if you go to the Google App Store and search for Cellbots Logger, that is a downloadable application, and it's the same application that we used in November for what we called our checkout. And you can download that onto your Android phone and basically duplicate the experiments for yourself.
That sounds pretty cool. Well, can you tell us a little bit about Spheres satellites and how they work?
Sure. The spheres themselves, they're about the size of a volleyball. We have 3 of them that are up on station. And how they move around, they use a CO2 gas thruster. They're tiny little thrusters that are on each of the various faces of the sphere. And it's able to fire those thrusters in such a way that it can move itself around in microgravity. It uses these tiny little ultrasonic beacons. So it basically uses ultrasonic sound to figure out where it is on station. And then inside of the sphere, there's a tiny microprocessor that uses the time of flight of sound to determine its location. Then what the microprocessor does is it uses a combination of those thrusters and figures out which ones to fire so that it can go from point A to point B.
That's wild, and a lot of people have compared these to the target droids that were used by Luke Skywalker in Star Wars to hone his lightsaber skills.
Absolutely. If you go back and talk to a lot of the engineers that were on the original team, that was a huge source of inspiration for that and a couple other free flyer projects that have been on the ISS and on shuttle.
Well, so with the upcoming work that you're going to be doing, what in kind of simple terms are you trying to learn?
Sure. One of the big things that we're trying to explore is the idea of allowing crew to do other things. There's a lot of if you've watched any of the ISS activity, you know that crew is very, very busy, and often the jobs they perform can be very dangerous. And we're trying to find ways to leverage telerobotics to help lessen the burden on crew and give them more time for interesting things such as science and mission-related tasks. On Earth, we're becoming very accustomed to having things like robot vacuum cleaners, and we hear about new developments like self-driving cars. Our research is similar, but it's in space. We hope to have robots on the ISS and in future missions performing a lot of the mundane and dangerous tasks that humans now perform.
And so I remember in the remake of Flubber that had Robin Williams in it, he had a little robot helper that flew around and helped him out. Are you looking at something like that, using spheres for use inside the station?
Absolutely, it is that's one of several different use cases that we're looking at. You can imagine the idea, like in that case, I think its name was Weibo, that it's kind of like a personal assistant that's there to kind of help him through his experiments and stuff like that. But you can also imagine scenarios where the robot is off doing tasks completely unattended. The astronauts have to do things like check for radiation. They have to do what they call audio dosimetry, and that's determining sound levels on station. And so you can not only imagine robots working in combination with humans as a teammate, but then them also going off on station and kind of doing their own thing and providing their own services.
Well, and I guess with a timeline is so packed for the crew all the time, that would free them up for additional research or other activities, huh?
Sure. The other thing that it does is it benefits ground control. So, as I'm sure you well know, there's a lot of cases where a camera isn't exactly in the right position, or it would be really nice if we could go over and look at this panel or see something that's been going on, in a different area of station from where you might have camera coverage. So you can imagine a case where you not only have the robots that are helping crew, but then you also have robots that are helping ground control and allowing them to fly and look in places where they otherwise might not have cameras or coverage or communications with the astronauts.
Oh, well, and so how, it's a little obvious to me, but maybe you could explain to our viewers how microgravity makes this experiment possible.
Sure. Well, for missions in space, microgravity is really how the astronauts work and live. For robots to work successfully in space, we need to know how to control them safely and productively. We take it for granted on Earth that we have a fair amount of friction and gravity and other things that are in our lives. So if you're in your car and you take your foot off the gas, the car will eventually roll to a stop due to friction and other effects. But when you're in microgravity and you fire a thruster in one direction, you're going to need to fire a thruster in the opposite direction to stop. And so there's a subtlety there. And also imagine trying to drive your car where there's a 1 to 2 second delay between what you do and what the car actually does. That would not only be difficult, but it would actually be very unsafe. And so our experiment is helping us design intelligent robotic systems that can enable us to work in microgravity and cope with these unique issues.
Well, so how do you get into this kind of research to help people that might have similar interest in robotics or in developing apps for space? What's your background? Where are you from? Where'd you go to school?
Sure. So I am a self-confessed geek. Grew up working and playing with radio-controlled cars and other kinds of good geekery. Prior to coming to NASA, I worked for about a decade designing robots for search and rescue and explosive ordnance, or sometimes called bomb squad robots. I grew up in Central Florida. So was always near Kennedy Space Center and have always been a fan of space science. I did my undergraduate and master's in computer science, and I've always kind of been a computer geek. I did that back at the University of South Florida, and I did my PhD at the University of Massachusetts Lowell, and I worked in robotics labs at both of those locations. Strangely enough, in addition to all of that, as part of my work in search and rescue, I'm also trained and certified as a firefighter, and I work part-time with FEMA and other search and rescue teams trying to figure out how to bring robotics and other technology to the field.
That's really interesting. Tell us a little bit about where you work at Ames now.
Sure. I really have kind of two locations that I work with here at Ames. One is in the Intelligent Robotics Laboratory, and we're a group here that works on not only free-flying robots like spheres, but also ground rovers, and basically anything that involves in robotics and trying to put intelligence into these machines that help and work with us every day. And then the other role that I have, as I mentioned before, is with the Spheres National Facility. And so we have a whole lab here we are able to fly the spheres more or less frictionless on a large polished granite table, and we can bring visitors in and other investigators in and allow them to fly their experiments on the ground in 2 dimensions before they actually fly them up on the International Space Station.
And there have been some student experiments too on that. Have you worked with students on this?
Absolutely. So that's probably the Zero Robotics program is what you're talking about, and my group in particular provides a lot, some of the technical support and other support features for that. That's actually mostly coordinated through MIT, and it is a huge, huge event. And talk about a powerful, combination of schools and other groups that allow these students to fly their algorithms up on the space station.
Well, thanks. You mentioned a couple of applications in your background, such as search and rescue. How can you apply the results of your experiments in space to helping people here on Earth?
Well, how we use robots in space is very, very similar to how we use robots on Earth in terms of them going into hazardous locations and doing mundane tasks. So you can think of a lot of examples like bomb squad robots, search and rescue robots, and even surgery robots nowadays. All these robots require a high level of precision, and our research in space can better inform how these Earth-based robots might be better designed in the future.
Well, that's really interesting, Mark. I really appreciate your being here with us today on the National Space Station Update. And we wish you the best in your activities next week and in the future using spheres and smartphones. And we hope you come back and talk to us again later and let us know how the whole smartphone thing works.
Absolutely. Thanks for having me on.
All right, thanks again. That was Mark Mazzeri from the Ames Research Center in Moffett Field, California, who's working with connecting smartphones to the Sphere satellites on board the International Space Station and testing new realms of robotic assistance to humans, both in space and here on Earth.